equilibrium and free body diagrams. In short, FBD. Right. Now, basically, presently in this module, we are learning mostly about statics, and it deals with equilibrium when the body is in static condition. Okay. And we are going to deal with force or moment will necessary and sufficient to maintain equilibrium. Right. So let us now see system isolation. System isolation and free body diagram in 2 dimension. Mostly we are going to see this now. Right. Now, before establishing the equilibrium of a body, right? First, what we need to do is we must, without any ambiguity, we must separate each and every component of a system or mechanical system. And we must clearly represent all the forces acting on the body. Okay. We should please shut your mic, please. Right. So we must represent clearly all forces acting on the body, right? We cannot omit any force or we cannot include any extra force because there will be, then obviously there will be errors. Okay. So a mechanical system, another important thing that you must know what a mechanical system is. So this is say number 1. Number 2 is a mechanical system it may be defined, a mechanical system may be defined as a body or group of bodies that can be conceptually isolated from all other bodies. From all other bodies. The bodies may be rigid or non-rigid, but mostly we are going to deal with rigid bodies. Mostly we are going to deal with rigid bodies. Okay. Now this free body diagram, the free body diagram is a diagrammatic diagrammatic representation of any isolated system treated as a single body. Treated as a single body. And finally, the diagram shows all forces applied to the system by mechanical contact with other bodies which are imagined to be removed. Okay, so it is imagined that other bodies are removed for the body that we are considering. Say we have 3 to 4 bodies in contact with each other. The analysis that we are doing for a particular body, we will be considering that the other bodies are removed. Okay. So with keeping all these points in mind, now let us see some important aspects of the free body diagram, right? First example. For the first example, say you have a string like this. So you know something about how to we have one more foundation is line and then suddenly so the first example would be flexible cable. Flexible cable or rope. Say the angle, this angle is say theta. So force exerted by a cable, of course flexible cable, a flexible cable is always a tension away from the body. Away from the body in the direction of cable. So what will be the force acting on this body by acted upon by this body by this string? It will be something like this.
Right now, I'm Center for Model Planning.
So your tension will be in this direction at an angle theta, right? This is one example. Your example 2 will be, say, a smooth surface. Say you have a smooth surface. Say you have two surfaces in contact like this. Okay, then if I wish to find out the force that is acting on this body, if we want to draw the free body diagram, so it will be something like this. Like this.
So you are also mechanical,
and you have a normal force like this acting on this body. So
have you ever read any subjects which is related to mechanical sciences?
So contact force is compressive
so it is more about
and normal to the surface.
Mechanics, where you must have a free body diagram and calculations of forces, all those kind of things.
Right? Say you have a rough surface.
So let me tell you.
Say in case you have a rough surface has many asperities. Okay, a rough surface has many asperities like this. Say something like this. Right? Say for any asperity, if we for any
the whole scope of application is limited to the building itself. So whatever we are learning, it is for application in the building.
For any rough surface.
There our intent is quite clear and limited. So that is why we want
there is a tangential friction force. Tangential
where our approach is to the
friction force
basic mechanism, and then how exactly we are
as well as
or how we can implement that particular
normal component.
So that we are our job is basically
right. So how does it look like?
So in case of the design,
we can just approximate it something like this. Okay. So this would be the normal component.
And then we also see special applications.
Say along this direction, we have the frictional force F, and you can have a resultant of this friction and normal force R. Like this. Okay.
Are you getting my point?
Next important part is your roller support. All these points that I am showing, they will be important for problem solving. That is why I am discussing it with you. Next, coming to roller support. Where can you find roller support? Can you tell me? In bridges, one end is on roller support, isn't it?
I think there is a lot common.
Yes, sir.
Right. So here you have a roller support, or you can have roller support in other forms, like this.
Especially in case of mechanical services, there is always a necessity of collaboration between
Okay, you can have a roller support like this. You can have a roller support something like this, especially for beams.
For I think both students from mechanical and civil. But please make it very, I'm making very clear that this subject
like this. Okay, so these are basic kinds of roller support. So what will be the free body diagram for this one? A normal force like this, or you can have a normal force at the hinge like this.
Integrate all those services in the built environment. What are its implications in terms of
so roller support,
so all those things which falls in the part
transmits a compressive force.
So let us begin with this force. So first of all,
Transmits a compressive force normal to
we are talking about mechanical services. So let us understand
supporting
exactly the meaning of mechanical services.
surface, right?
So first, let us break the subject down into two major keywords. First is the mechanical and second is the services. So what
Next important example
so can you tell us what is the meaning of
is your freely sliding guideway.
So there is an element of machine. So machine is also
Say you have something like this.
students of electrical also study machine. So how it is different or
Inside this guideway, this is sliding. Okay, inside this guideway, this is sliding like this.
So even when we are designing a mobile phone, how it is like
Right? If it is sliding, then what will you get?
electronics. Still there is a role of mechanical engineering.
On this hinge, there will be a normal force that will be transmitted.
Yes, sir.
Support
Other branch of
force normal to the guide. Guideway.
other than that,
The next one is again very important is we are going to encounter a lot of numericals on pin connections.
सर
So-
गाइडवे क्या होता है
Yes,
you know there are different buttons.
सर व्हाट इज गाइडवे
How does the
guideway means suppose if you just consider the piston cylinder arrangement in your cars, right? So
you know
the cylinder is like a guideway.
that is what
It only allows reciprocating motion of the piston, isn't it? It restricts the motion of the piston only in reciprocating motion, isn't it? There is no other motion. So only along this guideway, only along this guideway, this block, this is reciprocating. So that is what I am calling a guideway, freely sliding guideway. Got my point?
so can you give us some examples of mechanical
यस सर
Okay, so the next 2 points are very important. First one is the pin connection. The pin connection. So here you can have a pin ended joint like this, something like this. just like this. So at this point, this is again very important. I am telling you, there are two components acting here. One will be reaction in x direction and one will be reaction in y direction. Okay, and both of them will have a resultant. Okay, so this is again, I am repeating, this is very important. A freely hinged pin
in this case, we are talking about movement of fluid.
connection
So in that, that is also
is capable of supporting a force in any direction. It is capable of supporting a force in any direction in any direction in a plane normal to the pin axis.
Deals with the aspect of human comfort inside a building.
Now if I restrict,
what does the HVAC do?
if I restrict,
It either heats the air or cools the air. Okay. And then when we treated that here, okay, we are
restrict the pin
parts of the building.
such that
That is what we are doing. Yes.
the pin
So all of you prepare
is not free to turn,
make the classes a little bit more interactive, especially at the beginning.
is not free to turn, then
It is perfect.
it can also support
So
a couple M. So how will it look like? Something like this.
So
Say Rx, Ry and a couple. If I restrict the pin and do not allow it to turn. Okay.
context of building, not as a generalized term, but in terms of building, what do you understand by that?
Next, finally, is your suppose you have a built-in support.
Sir,
Yes.
can you just explain example 6 again? Once again?
So,
Just a moment.
Okay.
but what exactly is that? If I tell you to define it, because an example is in front of you, can you define it? Means, no need, I do not want accent definition. I want your understanding. Just frame your understanding.
The scale is visible to you.
Yes, sir.
So if I just
Yes,
hold
sir.
this scale, see, this is like a pin. If I just hold it with my two fingers like this will act like a pin. Okay. It is free to rotate. It is free to rotate, right? And if I pin it in such a manner, this is not free to rotate. Now, if I try to apply some force here, right, then it will try to turn my hand also in this manner. Just hold your scale and just try to feel it. If you hold the scale lightly, and if you apply some force, then there is no effect at this point. Near my fingers, there is no effect of turning, isn't it? There is no moment acting on my fingers. But if I prevent rotation of this pinned joint, if I just prevent rotation of it, now if you try to apply some force, you will feel that some turning moment is acting on the pin. Correct? Got my point now?
Yes, sir.
Great.
Yes, sir.
Just use your skill and try to feel it.
That is also very important. So I think.
Okay, so coming to built-in support. I'll show this again with the same example. Okay, built-in support. Suppose a beam is built into the wall. Okay, suppose a beam is built into the wall like this.
So do not silence. Take it as an opportunity to express your ideas in the class. Okay. Is it fine? Yes. Okay. So,
okay, now this beam,
in this class, we have
say the beam
very technical or
is
very specific kind of things, but I want to bring
built inside a wall. You'll see that the basins, support for basins, and many other supports at your home, support for geysers, right? In many cases, you will see support for ACs that some iron beams or angles, they are built inside the wall. Okay, sometimes the provision is there, they are built inside the wall. Then in that case, what will happen? What will be my free body diagram? In that case, at this end, what are the forces that will be acting? At this end,
we need, air conditioning.
you will be having an axial force. Obviously, these directions will depend, say Rx, Ry, M. Okay, the direction of all these forces that I am showing, they will depend upon the equilibrium condition. Okay, initially you can take it in any direction. You apply the condition of equilibrium and you will get the direction of force. Right? So this is axial force. This is a shear force V, and a moment will be acting. A moment will be acting. So a built-in or fixed support,
Water supply, electrical,
a built-in or fixed support
sanitation services,
is capable
HVAC, firefighting, all of them are very important. I think that
of supporting
then no matter how good you build it,
an axial
it is not going to perform
force F,
it is not going to provide the necessary
a transverse shear force,
which is needed for productivity. So, the role of services is very important. Not just about
classical
making, like as a civil engineer, how to design a good RC system. But
a built-in or fixed support, it is capable of supporting an axial force F, a transverse shear force
if they are not working properly, then
V,
the whole purpose of designing the building gets to be. Okay?
and
So,
couple M,
this is one. So because first we are
which is
talking
basically
about
also called
HVAC part.
bending
Can you
moment.
tell me how old are these HVAC services?
To prevent
Air conditioning
rotation.
Maybe just
Okay, now just again switch on my camera.
parents, I think AC was a very rare commodity.
See here.
Okay,
Now hold your scale like this. Hold your scale like this. Okay. Hold your scale like this. Now apply some force like this. Now apply some force like this. And try to feel the forces that are acting in your hand. Okay. Like this. Just hold it, grab it like this. Now if you try to apply some force, see, there will be some turning action or moment acting at this point near your hands. Okay. There will be some shearing action at this point in the perpendicular direction when you are applying this force. Some force in y direction, and when you are applying this force, this scale, it will try to come out of your hand in axial direction. So it is also supporting an axial force. It is also supporting an axial force. Is it clear to you?
Yes, sir. Yes.
So, in the human component,
Right. So this is your built-in support, and you already know if you have some body where you have to take into consideration the
there is a very limited zone of temperature.
gravitational attraction also.
So,
Also, in some cases, in some cases, gravitational attraction must be taken into account, which is basically the weight of a body. Okay, W equal to mg, right? Spring forces, we are not going to discuss it right now. We will discuss it later. Now coming to equilibrium condition. Coming to equilibrium condition. Coming to the equilibrium condition, for 2D case, summation of forces in x direction equal to 0. Summation of all excuse me, summation of all forces along y direction is equal to 0, and summation of moment about all point, that will be equal to 0. Okay. So a body is in equilibrium if all forces and moments applied to it are in balance. right? So this is the thing that we must be keep in mind. Next, another thing that we need to keep in mind is different force systems.
Basically about planning, design, regulation, safety, aesthetics, and actually more important. So nowadays because we have got mechanical services, we can design
Right.
like this.
The first one is collinear.
It's a very famous building which is located in Spain. Bilbao,
Say you have a body like this.
Bilbao, Spain, and designed by
Say you have force F1 like this. Say you have force F2 like this. Say you have force F3 like this. And this is say your X direction. Then you have summation Fx equal to 0. So this is basically a collinear system of force. Number 2 is you can have
all these things are
concurrent at a point. Then say you have a body like this.
Get air from the outside.
You have F1 like this, F2 like this. You can have F3 like this, and you can have say F4 like this. All of them say meet at a point O. Then in such a case, summation Fx equal to 0, summation Fy equal to 0. That will be your equilibrium equation. The third one will be parallel system of force. Say F1, F2, F3, etc. You have say something like this. Say you have F4. Then in such a case, summation of all forces along X direction equal to 0, and moment in Z direction. Z means perpendicular to the paper. Okay, that should be equal to 0. And the most generalized case, you have a body like this. You can have forces F1, F2, F3, and say you have some moment externally acting on it. So in this case, summation Fx equal to 0, summation Fy equal to 0, and summation Mz equal to 0. So this will be your equilibrium condition. Okay. So with this, we complete our basic theoretical portion on free body diagram and equilibrium in 2 dimensions. So tomorrow what we can do is we can practice some free body diagrams. We are going to take a number of cases and we are going to solve that. And we are going to draw free body diagram and find out equations of equilibrium. We can do that in tomorrow's class. Any problems up to this? So in today's class, you have learnt about system isolation and free body diagram. So basically, what do we do in free body diagram? We represent clearly all forces acting on the body. Basically a mechanical system. The bodies may be rigid or non-rigid. Here we are going to deal mostly with rigid bodies. And free body diagram is diagrammatic representation of any isolated system treated as a single body. Okay, the diagram shows all forces applied to the system by mechanical contact with other bodies which are imagined to be removed. Okay, we just isolate it from other bodies. Then we saw free body diagram for flexible cable or rope, the tension acting because of that. For a smooth surface in contact, for rough surfaces in contact, for roller support, for freely sliding guideway, for pin connections, for a built-in support. With the example of a scale, I have shown you how this pin connection or how this built-in support works, right? Then we define the equilibrium condition, which is your summation of forces along x, y direction is 0 and moment should be 0. You can have collinear system of force. You can have concurrent system of force, forces that are concurrent at a point. You can have parallel system of force, or you can have any generalized system. With this, keeping this in mind, we are going to proceed tomorrow with numericals based on free body diagrams and equilibrium.
Excuse me, sir.
Yes,
Just a suggestion, sir.
not getting your point.
I want to say something. Can I, sir?
You want to?
Say something.
Yes, say. That is what I am asking. What are you saying?
सर दूसरा प्रोफेसर का बहुत नॉइज आता है. आप दूसरा रूम में जाके क्लास ले सकते हैं अगला क्लास से.
क्या?
फ्रॉम टुमारो ऑनवर्ड्स आप किसी और रूम में जा सकते क्लास लेने. दूसरा प्रोफेसर बहुत का नॉइज आता है तो थोड़ा लैग हो जाता है.
टाइप करके बताओ ना थोड़ा चैट बॉक्स में. क्लियर नहीं आ रहा है.
Sir,
Yes,
sir, please share the PPT.
I didn't share it.
No, sir, today's PPT.
I didn't share the PPT.
There's a last class
Right.
PPT.
Okay, I'll
Last.
share it. I'll share it today. I'll share it today itself. You have got everything.